Okay, class, picking up where we left off at. We finished problem 5. Now we're on problem 6. And you can read all of this at your leisure. But we have the example. It says an infant weighs 4 kilograms. What is the required amount of fluid per day in milliliters? So we will have 4 kilograms. And we will multiply it by, we notice 4 kilograms is in this weight range. So that would be 100 milliliters per kilograms. So we will take 100 milliliters. Per means division. So it would be per 1 kilogram. And then we can put this over 1 and simplify out the kilograms. So we would end up with 400 milliliters. Because it would be 400 over 1, which is just 400. So now, we go down here to number 7. It says, given an order and quantity of mass per time, determine the necessary IV flow rate in milliliters per hour based on a given mass per volume. These types of problems are often used in critical care nursing. Example, give patient 500 milligrams of dopamine and 250 milliliters of D5W to infuse at 20 milligrams per hour. Calculate the flow rate in milliliters per hour. Note, not all information given may be relevant to the solution. Start by deciding what you need to calculate, then work backwards. Okay, so now, this is basically the formula. We have the order per hour divided by the guess what we have. Then we will multiply that by the volume, which is in milliliters. And that equal to Y. Now I have to put this in parentheses. This is the flow rate. And it's in milliliters per hour. Okay, so now we have the order per hour. We have the 20 milligrams per hour all over 500 milligrams because that's what we have. Then multiply by 250 milliliters, and then we will put this over 1. Now, just to show a couple things here, we could rewrite this fraction here. We can make this 20 milligrams all over 500 hours, milligrams, hours times milligram, times 250 milliliters over 1. Now let me explain this. As far as these units, this is basically a fraction over a fraction. Whenever you have a fraction over a fraction, you would take the denominator of both and multiply them. So hours and milligrams will multiply by each other. So this will show you that milligrams and milligrams simplify out. So we would end up with 5,000 over 500. Well, it'd be 5,000 milliliters over 500 hours. And that would give us 10 milliliters per hour. And that will be the final answer. Now, it's problem number 8. There's a lot to problem number 8. So I'm going to do this by steps. It says here, a doctor orders 200 milligrams of whatever this R is to be taken. You said what it is? Rocephin. It's antibiotic. Okay, rocephin. To be taken by a 15.4 pound infant every 8 hours. The medication label shows that 75 to 150 milligrams per kilogram per day is the appropriate dosage range. Is this doctor's order within the desired range? So now we want to convert Actually, the first thing we would do is convert the 15.4 pounds to kilograms. So we have 15.4 pounds, and we will multiply this by, it takes 2.2 pounds to equal 1 kilogram. And after we multiply this out, we know the pounds will simplify with pounds. So we have 15.4 over 2.2. These are kilograms, and that will give us 7 kilograms. Okay, now we go to number, so now we have 7 kilograms. So we would take this here. We need the weight in kilograms, which we just did, and multiply by the dosage per kilogram. And that equals to Y, which is the required dosage. And I'm going to abbreviate required for dosage. Okay, so now we have our weight in kilograms, which is 7 kilograms. And we have multiplied by the dosage per kilogram. Now we have 75 to 150. So we're going to take the 75 milligrams per kilogram. We're going to take the lowest amount, and then we're going to take the highest amount. So we know if it falls in between this range we're fine. So this will give us 525 milligrams. And this will give us 1,050 milligrams. Now this right here, and I'm going to abbreviate, this is the, I can spell it out. This is the minimum dosage. And down here is the maximum dosage. So now we know our minimum and maximum dosage. So now we go to number 2. This is where we deal with our time. Now, we know that there's 24 hours in one day. And we're told that this is dispensed every 8 hours. So we would need to change hours, the 24 hours. We need to divide that by 8 hours to determine how many times per day we give this. So it'll be 3 times per day. So we would take our 200 milligrams and multiply by 3, and that would give us 600 milligrams ordered per day. So that's how much they said that the doctor ordered. Okay, so now we will go to step 3. 600 milligrams, that's in between that 525 and 1,050, right? So that means that we're good. So 600 milligrams is within the desired range. Of 525 through 1,050 milligrams. So this solves the problem, but we also have to answer the question. And the answer is yes, the doctor ordered a dosage within the desired range. Are there any questions? Okay.